we're talking about the limits. Essentially, when you're looking at a limit, imagine you've probably done this before. You're going to your nose, right? So you want the left side limit to equal the right side limit, and therefore that limit will exist. In the first example up there, I have a laser pointer. You can see that the left side and the right side both come together to equal the same value, even though that value isn't defined. That is a-okay. That limit exists. But in the middle example, it's not defined at x equals 2 because as you come over from the left side, it equals 2. And as you come over from the right side, it approaches, I don't know what that's like, -9. So that limit would not exist. And then obviously a straight line, that limit is going to be defined everywhere. Does that make sense? So for the definition of a limit, all you're looking for is whether the left side of that limit equals the right side. That is how you know that the limit there exists. What are some ways of solving limits? So there's, I think, 7 kind of ways of solving limits. The first thing that you should always try is direct substitution. Okay? So that is where the limit as x approaches a value, all you do is you plug in that value into the limit, and then you see what that returns. If that returns 0, you're good. You're chilling. If that returns infinity over infinity, you're not good. You're not chilling. You got to do something else. All right? So those are called indeterminate forms. There's a bunch of them there. Really ignore everything after the first 2. All right? So infinity over infinity and 0 over 0. Those are the main ones. If you remember those, you should be fine. All right. So you've plugged it in. Here, all right, we plug it in, we get 4 minus 4 on the numerator, which is 0, which you might start, being a little nervous. But then on the bottom, you have the square root of 2 minus 3. That's like some negative number. So it's just 0 over a negative number. You're good to go. But let's say that that was actually 0 over 0. Now, there's some other things you can try. You can try factoring. So this is the next thing you should try. So if you see kind of 4 different terms, or you see 3 terms that look like a polynomial that would be easily factored, you, for the most part, will be able to factor that out and then divide out the denominator, which then leaves you a term which isn't like rational function, and then it'll just be 0, or it'll just be a number, and it won't be 0 over 0. Does that make sense? Okay, those are the easy ones. There's a few more complicated ones of solving limits. So if you're seeing fractions on the numerator, probably it's going to be use a common denominator. So all you do is, for the one in that example, you're going to multiply by a common denominator. So it would be 1 over x times 2 minus 1 over 2 times x. And then you'll be able to evaluate that. Let me know if you guys like, I can work through some of these, but I feel like it's a little more so review for you. And then that'll basically allow you to, again, cancel out the denominator, which is what you're trying to do in the end, and then you'll no longer have an indeterminate form. The next type, which is pretty common, if you see a radical, odds are it's going to be multiplied by the conjugate. What that is, it's a little bit of difference of squares, but basically you're multiplying both the numerator and the denominator by essentially the 2 terms, but instead of having a negative sign, you have a positive sign. Instead of having a positive sign, so basically you're getting rid of the radical by squaring it, like doing the difference of squares. So then on top, rather than having the square root of a function, it would just be x squared minus 4x plus 20 minus 4 squared, which would be 16. And then now your denominator will have that radical term, but rather than a minus, it'll be a plus. So then the denominator will increase in value because it's not going to be multiplying by 0 because it's a plus sign instead of a minus sign. Another way of solving limits for when there's an absolute value is using the definition of it, so one-sided limits. So this is primarily for absolute values, but just remember that the absolute value of x when x is less than 0 just equals negative x. Oftentimes when you're seeing functions and there's absolute values, it's kind of scary and I don't like them. But if you just substitute, if you know that x is going to be less than 0 over a certain range or a certain interval, you can just substitute that absolute value of x for negative x, and it will make it look a lot nicer and a lot simpler. The other trick, which is actually, I think, most used, I would say, is for when you're going for a horizontal asymptote, or when the limit as x goes to positive or negative infinity. And there's kind of 2 tricks for doing this. One is multiplication by the highest power, and the other is factoring out. Multiplication by the highest power is essentially if you have I'll do an example. This will be good. Essentially, if you have like x squared minus x over x squared plus 1, you'd be multiplying both the top and the bottom by 1 over x squared, which is basically just multiplying by 1. And then what this will give you is it'll give you x squared over x squared minus x over x squared. So then this will reduce to just a constant, which would be 1. But then this, since the denominator will grow exponentially large, faster than the numerator, that will just approach 0. So you can ignore it. So that's kind of the trick that you use with multiplication by 1 over the highest power. And then the second trick, which is really helpful for radicals, is if you have a radical on top, we'll just say that. It might be a little confusing for evaluating this, but if you imagine by you're factoring out this portion of the radical, so you're factoring out a square root of x, and then you're left with what you have to multiply in. So that would be 1, and then plus x over x squared. So this is a really handy trick for complicated radicals, but basically then if you multiply this, now this term will be x squared, and then this term will be x, which is what you have before, and then square root of x is just x, so then you can do like highest powers. Does that make sense? Any questions on that? Okay, sick. Lastly is L'Hopital's rule. Also, if I'm going over anything too quickly, just ask me to clarify. I won't judge at all, I promise. I know I can go quick sometimes. But yeah, okay. So the next one, the last one, is L'Hopital's rule. You don't have to use it, but if you do use it, there are just a few things to keep in mind. First, it has to be in an indeterminate form. So either 0, 0 or infinity over infinity. Those are the only two indeterminate forms that it will work for. And then the second thing is as you take L'Hopital's rule, which if some of you aren't too familiar with it, basically you'll have a rational function. Let's say it's f of x over g of x. And then all it is that limit will equal f prime of x over g prime of x. And then you can keep doing that. So you'll have f double prime, f triple prime. You keep doing that up until the limit exists. So that's essentially the premise of L'Hopital's rule. But what they teach is there's just a few things that you have to kind of state in order to use it. One, you have to state that it's in indeterminate form. So just write a little thing. This limit is indeterminate 0 over 0. That's the first part. And then the second part, it's kind of a little circular. After you've taken L'Hopital's rule and done it multiple times till the limit exists, then you just have to make a statement, because the limit exists, L'Hopital's rule works. It's circular like that way, but basically if you put those two statements, you should be fine and you shouldn't lose any marks for using L'Hopital's rule. The one thing to note is that you can't prove a limit doesn't exist with L'Hopital's rule. So if through doing L'Hopital's rule, your limit doesn't exist, you have to try another way. You can't just say limit doesn't exist because L'Hopital. And then the last one is kind of what we did over here by multiplying by 1. If you just have a function that's not a rational function, but you want to use L'Hopital's rule, you can multiply it by, and it's not in like one of those indeterminate forms, you can multiply it by 1, so like x over x, or whatever that may be, to reduce that. So kind of an example would be if you had like ln x, and you'd essentially want to change that into indeterminate form, you could just multiply it by like x over x, and then that would give you a rational function. So essentially, always remember you can multiply any function by the same number over the same number, and that'll give you a rational function that you could use L'Hopital's rule for.